Bismillahirrahmanirrahim. Assalamu alaikum students. Today we are going to discuss another problem. So let me write the problem. Our problem goes like this. It says a proton is placed in a uniform electric field E. What must be the magnitude and direction of this field if the electrostatic force acting on the proton is just to balance its weight. So this is our problem. So before going to the solution, let me check the problem and let us understand it. The proton is placed in a uniform electric field. What must be the magnitude and direction of this field if the electrostatic force acting on the proton is just to balance its weight? We know proton. If this is a proton, it has a positive charge. As you know, it has positive charge. And how much is the charge on the proton? Of course, the charge on the proton is equal to E, and that E, you know, is 1.60 into 10 raised power minus 19 coulomb. So proton is a positively charged particle with charge E equal to 1.60 into 10 raised power minus 19 coulomb. Proton has mass. It has mass, and you know mass of the proton is 1.67 into 10 raised power minus 27 kilogram. The mass of the proton is 1.67 into 10 raised power minus 27 kilogram. So you know if you place proton at Earth, so it will experience pull of the Earth because it has mass, so it will be gravitated by the gravitational pull of Earth, and its weight will be, that is force experienced by the proton towards the center of Earth, will be mg, where g is the acceleration due to gravity. So it will be weight of the proton, where g is acceleration due to gravity at the surface of Earth, 9.8 meter per second square. So if I have a proton it will fall due to the pull of Earth. And that pull in magnitude will be equal to mg, and direction of that pull will be downward. Now the question says, we place this proton in a uniform electric field. Uniform electric field means that the electric field vector has same value at every point in space. So when we place it in a uniform electric field, that electric field should be such that the electric force experienced by the proton due to that field should balance its weight. So it should float. You know, if you have a charged particle having charge Q, you place it an electric field E, then it experiences electric force F given by QE. That means the magnitude of the electric force is QE, and the direction of the force is same as the direction of the field if Q is positive, and if Q is negative, then the direction of the force is oppositely directed to the direction of the field. Now we have this proton, and I have Earth here. This is my Earth. So Earth is pulling it down. I call that Fg, which is mg. I want electric force to act on it in upward direction. Since it is positively charged particle, so if I want electric force on the proton to be in upward direction, that's only possible when field is upward. So E is upward. So direction of the electric field we have found is upward. Now how to find the magnitude is simple. The electric force on the proton in magnitude must be what? Gravitational force, right? If Fe is electric force and Fg is the gravitational force, so in magnitude they must be equal. Now the electric force will be Q times E, but Q is E, so it will be EE, and gravitational force will be mg. So the strength of the electric field or magnitude of the electric field is mg by E, right? So when you substitute the values, 1.67 into 10 raised power minus 27 kilograms for mass, then you have 9.8 meter per second square for small t, and E is 1.60 into 10 raised power minus 19 coulombs. I have equated the electric force with the weight, and I got E equaled mg by E, m is mass of the proton, which is 1.67 into 10 raised to minus 27 kg. Small g is acceleration due to gravity, which is 9.8 meter per second square. Charge on the electron 1.60 into 10 raised to minus 19 coulomb. So when you do the calculation, you will get it 1.0 into 10 raised power minus 7 Newton per coulomb. So this is our answer. So if I have a proton and I want its weight to be balanced by an electric field, then the electric field in which I place it should have the magnitude 1 into 10 raised power minus 7 Newton per coulomb, and and it should be directed up. I hope we got the problem. So it was easy. But don't waste your time. Go through these problems. It is interesting. And don't forget to like, subscribe, and share my channel. You can comment in the comment box as well. Thank you. God bless you. Assalamu alaikum.